Yeah, we had about remote repository, right, with GitHub. Yeah, so GitHub with remote repository. So how do we create how do we sign up that in the GitHub account? And once that sign up is done, how do we create a repository within the GitHub? And once that repository is available as a developer, if you'd like to work it from about our developer system, then how do we clone that remote repository? Yeah, so in our local developer system, create one directory. So wherever you would like to clone that, yes, create one directory, then go ahead, clone the remote repository, whether GitHub or GitLab or Bitbucket, doesn't matter that. Yeah, so this URL, the remote URL, simple. Whether that is even internal about our GitLab server also, internal server also, the URL is required. Yeah, git clone and the URL, which helps about it to clone it, the remote repository to the local one, then go to the directory, then whenever you clone it, it is going to create local repository, right? So .git folder already it is generating that. You don't need to create it locally. But if you are doing from the scratch about your folders or about your existing projects, then what is the command to create a local repository?
Git init.
Yes, that is a git init. But normally we don't see this git init creating the local repository. So to are joining to the project is nothing but already projects are available in the remote repositories. But what is the command we use it is, that is a git clone. Yeah, once clone is done, then you will be having that in your system, the working directory, the remote repository files, you got it. But if you have done this any files update or modification or creating the new files or deleting the files, then you need to stage it, then commit it, then push it. Then other developers, then they can pull it. Yeah, this is the process model also we are trying to understand it. So what is the command to stage the files? What is the command, git command to stage the files?
Git add song.
Git add, sir.
Yeah, git add command, git add, and then we need to commit it, that is git commit. Then we can push it, that is git push. And what is the default alias name of the remote repository?
Origin.
Origin, yes, git push origin, and a branch name. Under default branch, you will be having either master or main branch. So that is about the process. And we are understanding some more commands also, like git status command, git show command. Suppose if you know the commit ID, how do you know that in that commit, what are the changes that have been applied? Or how do you compare with the current commit to the previous commit? That is git show and commit ID. That is one more command. And how do we get it list of all the commits which are happened in the repository? Git log command. Git log, which is have the different options which we are trying to understand, author based logs, file based logs, one line based logs, and the latest commits. If you latest 2 commits or 3 commits, you would like to see that -n option. Yeah, so there are some other commands which you are understanding. Yeah, git log, git show, git status. Yeah, right. Yeah, you can find it all these commands here. Yeah, git restore command also. Git restore --- stage and the file name from the staging area to revert back to the workspace area. Yeah, you can remove the file directly. So suppose if you don't need that any file, git rm and the file name, then you can commit it. And one more option which you are understanding, git commit -a and m. What is the meaning of this one? So you don't need to run it 2 times the command git add and git commit. So you can stage it and commit by using the git commit -a and -m. Git blame command, I will come back to that. Yeah, so there are the commands we are understanding. But today let's talk it that the one more important scenario, the real-time scenario. So whenever we are working as a DevOps engineer or among the development team, they are going to face that some challenges. And as a DevOps engineer, we need to provide the solutions to them. But what are the challenges? And those challenges related solutions. So that's especially whenever we are talking about parallel development. But what is this parallel development? Yes, let's look into that. Are you clear about these points? Any queries, questions from the previous section, please let me know before moving to this.
So we are good.
Cool. Yeah, if you go to this about our GitLab, is a repository in the last section, which we are creating that, right? Batch 48. And we were doing some dummy files creation and updating that. Fine, I'm going to continue with the same repository. But today the scenario, what we have to see is, so this is about our remote repository. That is GitHub, the remote repository. And we have the repository name, something batch 48. Yeah, this is about our remote repository state. But here 2 developers are working. In the last section, from one developer point of view, which you are understanding. That is git add, git commit, git push. So that is what, I mean, any developer he is working, those commands required. But today let's have it among the development team, as we are talking that 2 or more developers will be having. So what are the challenges they will be having that? Suppose, so he is the developer 1. So he is a developer 1 and he is a developer 2. So each developer is going to have their own system, right? Their own local the desktop or the laptop, whatever they are using. So they need to set up their local system. Yes, as we know that, how do you clone the repository? So initially, so any developer who is joining to the project has to clone the repository. So this developer 1 also cloned the repository, that is batch 48, and this developer is also cloned the same repository. So both are working on the same project. Repository is in the GitHub. Okay, so if he is developer 1, he is working on the, let's assume that in this repository, the module 1, and he is working this on the module 2. So these 2 developers, if they are working this on the different modules, so this developer, so maybe he is working on Ansible, and this developer he is working on the, let's assume the Jenkins as DevOps engineers point of view. So both 2 DevOps engineers, and he is working on the Ansible and he is working on the Jenkins. Whenever we are committing the files to the remote repository, so he will be having his modules and he is going to commit it to the remote repository, and he is having his Jenkins module different and Jenkins files he is going to pushing to the remote repository. Then we don't see any conflicts because both are working on the different modules, no issues on it. But the problem, the where it comes to is, suppose he has to work it on the Docker file, And this DevOps engineer is also working on the Docker file. So both are working on the same file. Now there's a challenge. Same file. So if both are working on the different modules, no issues. So my module related files, whatever I'm implementing, whenever I commit to the remote repository, those are all my folders. Nobody is going to touch it. Or you are working in your module about your files and nobody will touch it until there is integration is required. But here in the project, one more scenario what we'll be having is sometimes we need to work it on the same module, and in that module, same files, and in the same files also same lines. There the problem starts. Yeah, I'm working on this Docker file and you are also working on the Docker file. And initially both are having the same file. But what I have done in this Docker file, as per my changes requirement, I have modified some content in the Docker file. And I have updated to the remote repository. So this developer one has committed to the local repository, has pushed it to the remote repository. But this developer, he doesn't know the changes which are done by the developer one. But at the same time, parallel, that is the meaning of that. At the same time, this developer too, he is also working on this Docker file. Because initially the both files are the same, right?
Yes, yes.
Yeah, so this developer too also, he is working on the same Docker file. And the same, that lines like something, same lines he has modified. And he is also trying to commit it. But he has already done in the same file, suppose some 10 lines already, the initial state was 10 lines have been implemented. Now he has done at the 11th line. And he has committed to the remote repository. And developer 2 doesn't know that change, and the developer 2 is also trying to update his changes in this Docker file at the line number 11. He has modified as per his changes and he's trying to push it. Already the Docker file, the state what do we have? 11 lines which we got it here. Already that is updated by the 11th line by the developer 1. And the developer 2 is also trying to update that. 10 lines, both are the same, but 11th line he is also trying to change it. Already developer 1 he has done some change. And developer 2 is also trying to do the same file, same line. Now which line it has to take it? Is it going to override that? Developer
No,
change?
no, sir. We are getting the errors or conflicts error. Can't do.
Yes. So whenever he is trying to do that, the Git, what it is trying to do, it is trying to auto merge. If it are two different files and the different lines, no issue. So taking his changes and updating here, there is no issue. But here the same file, already 11th line he has updated. And now this developer 2 also has modified the same file, same line, and he's trying to push in. But which line it has to be taken? Is it going to appending or is it going to overriding? What is going to happen that? It doesn't know it. What it has to be done. So what's going to happen this is, it is going to throw the error to the developer 2. Boss, already in the remote repository, we have the latest commit, which I cannot take it about your commit. So it shows that conflict error. So whenever we have the conflict error, what do we need to do that? And how to fix this one now? Now this developer 2 has to take the responsibility because developer 1 he has done first. He is safe. Now the developer 2 he is trying to do that, but already in the remote repository some changes are there. And developer 2 also has to do that. Some changes, then how it has to be handled. this situation.
So developer 2 has to use the new clone on data, then modify it.
Yes, let's do that activity. First, let me replicate the scenario, this scenario. So already we have this Windows system. So I'm going to use it Windows system as developer 1 system. And I take it, that's one EC2 instance. And we use it this EC2 instance as like a Linux system or whatever, it doesn't matter that. So we use that Linux system as a developer 2 system. The first, the same repository will be having that. Then developer 1, the Windows system will come back and the Docker file already we have. And this Docker file will do some changes respective to the developer 1. Then we'll push that change to the remote repository. Then we'll come back to the EC2 instance and we'll try to modify it and we'll try to push it. Then we'll see this, what is the error. Then whenever you are having this kind of the errors, what you need to do that? Fixing that error point of view. Are you clear this scenario now?
Yes, sir.
This is one of the important and regular activity which we see that. But to overcome these conflicts, what is the permanent solution? That is also will come back. Yeah, so this is the scenario. Let's go back to the, let me quickly launch that one EC2 instance. Already Windows system we have, so no issues, but I need that. The one more, the Linux system. Let me launch it quickly.
So the easy scenario will be developer 2 can inform developer 1 to do the task, sir.
Sorry, developer 2.
Just inform developer 1 to do the same line update.
Yeah, we'll see that. I mean, how that would be. We'll try to replicate it, then we'll talk. Just let's bring that scenario, then we'll understand it. Yeah, obviously that's required. The communication between the developer 1 and developer 2 is required. Yeah, let me launch this one instance. So I'm just going to call this one as server. Let me use it Amazon Linux 2 AMI. T2 micro and key pair is required to connect it. Let me choose the key pair. Which one I am having that? Okay, let me create a new key pair. Okay, good. So remaining properties, okay, SH, let's check it. SH has been enabled. Fine. Now, meanwhile, on the Windows, so already we were having this on the Windows system, right? So let me go back to that about our workspace. D drive, the workspace and batch 48. And here I also have the Git folder. Here we are doing that activities. Yes, this is the repository. First, let me update everything here. How do you update that repository? First time we do the clone, but next time onwards, we do that update. How do you update that remote repository changes to the local one?
No.
By using git pull command. Yeah, already up to date. I don't have any issues. Let me go back to the EC2 instance now. And now the EC2 instance also will create the local repository. Let me go back to the EC2 instance. Yes, this is the instance. Let's take it a public IP. Let's use a mobile XTEM to connect it to this instance. Server.pem file, so select it and connect it. Okay, so we are good. So what I do is I'll clone that repository by using git clone. First time we are doing, already git is available or not. Let me check if the git. Git is required, right? Git -version. Yes, that's git command not found. But on the Unix operating system or Linux operating system, how do we install the git? On the Windows, we are talking about the git bash. But on Linux operating system, that git package is available. Go ahead with the git package, that is minstall git or apt install git. And now if you verify this git version, so if one is not required, directly you can run it. Version, yes, this is the version of the git. We are good. Git is ready. So let's go ahead. I'm going to clean the screen.
Sir, just sorry. On Windows EC2 instance, so we have to download like normal. Just go browser, download it, or you will have in centralized softwares from AWS to download and install it, sir.
Oh, sorry, I didn't get you that.
So example here, it just update. We will install the any software in Linux, but in Windows we have to go to specific website, download the exe file, then install it.
Correct.
So
that is git bash.
Git bash. So just in general, so AWS allow us to give any centralized place where all the software is available, or I can just go ahead and download it from any website.
Gitwise, right? You were talking that, or this one?
Not specifically Git, any software.
Okay.
On Windows based servers.
Okay. AWS is not providing. AWS is not giving that kind of the service, managing that all the repositories. That is out of scope for that.
Okay, you will have internet. You can just download an exe
Yes.
file, then install it.
Yes, exactly.
Okay, thank you.
So suppose if I need the git bash on the Windows, git bash is software from the git SCM. That is not from. See, this is a different different site, different provider. So which you can go here and you can download it, but you need to have this internet. And even from the Google also you can go to that. Suppose if you don't know that, like that gitsm.com site URL, go to the Google and just search for that, download git for Windows. Anyway, it is going to redirect into the gitsm.com. So just to have the internet. This is not specific to that any Amazon packages. Only infra we are using. EC2 instance point of view, I have used AWS, but remaining GitHub is also third party one. So we are not using, this is not belong to that Amazon one.
Okay.
So this is third party one. So only infra we are using about AWS one. That is now a developer 2 system, whatever I have launched. That is, the virtual machine, whatever I have launched. This virtual machine I have taken from the Amazon. Remaining all are like a GitHub or Git, even the Git version also, this Git package, whatever we have installed, this is also from normal Red Hat RPM repository. So RPM team, they are managing the repositories. So all these packages, that is install we have done. So only we have used it for the timing, the infra point of view, only EC2 instance from the AWS. Okay, good. So let me clone the repository. We don't have the repository, right? We didn't clone this. So we didn't clone this so far. So let's go ahead and clone the repository. So this is about our GitHub repository. So you can clone to your system also. So if you hit this URL in your browser, you will get it this the repository, and you can take this link, copy the link, and go to your system. And what is the command? Git clone, whether that is on the Windows operating system or Unix operating system, this is the same command. Yes, that has been cloned. We are good now. The repository name batch48 has been cloned. This is my developer2 system. Now developer1 and the developer2 both are having the same repository. So GitHub, we have this repository, and developer1, yes, he has updated, and developer2, he has also updated. That means from the Windows system, yes, we have cloned, to the Windows system we have cloned, and as well as to the EC2 instance also we have cloned it. So this is the initial scenario. Are you clear about this so far?
Yes, sir.
Yes, sir. Yes, sir.
Okay, now the problem what we are going to try to understand is both are going to work it. Now this developer1 is going to work it on this Docker file, and this developer2 is also going to work it on this Docker file. So let's try to observe the first what is the state of the Docker file. Yes, now first if you observe this in the remote repository, this is about our GitHub. GitHub, whatever I'm talking, GitHub, what I'm representing is a remote repository. Remote repository, what is the content we have? Docker file we are targeting now. Okay, 4 lines we have. Some previous changes in the last class, whatever we are doing, all the changes are available here. And now let's observe the developer1 changes. Developer1 changes. Windows system, right? Windows system if I'm using, that is Git bash if I'm using, just thinking about it, that is developer1. So what is the state of this Docker file? Let's check it. Yes, what are the remote repository changes we have? 4 lines. Here also we have the same. So remote repository, whatever we have, the GitHub, the developer1 is also have the same changes. Now let's go back to the developer2. Developer2 I'm talking is nothing but that is about EC2 instance. Yeah, this statement I'm using is nothing but thinking about the developer2. Yeah, he's also having the same state. So now the remote repository, developer1 changes, developer2 changes, all are same. Okay, now the scenario comes into the picture. What is the scenario? So now the developer1, he is going to start working on it first. Developer1, he is going to working on first, and he is modifying some changes in the 5th line. 4 lines already there. Some 5th line he is modifying as per his requirement, and he is going to committing and pushing to the remote repository. Let me do that activity from the developer1. So developer1 is Windows system, right? Yeah, let me edit the Docker file. So he's trying to starting his implementation. So what he's going to do, let me add it some content. This is 5th line from developer1. Okay, he has done some change in the 5th line. And if you check the status, Docker file has been modified. What is the content he has modified? How do you know that? Git diff command, which you can use that. So what is the content he has modified? Yeah, 5th line is added from the developer one. So he has added fifth line. Okay, good, no issues. Now he has to commit it, right? Let's first add it. That is the staging area, the Docker file. Adding, committing, changes from developer one. Let me add some proper comment, that is Docker file changes from the developer one. Okay, he has committed to the local repository. Then this developer one, he is pushing also. He's pushing to remote repository. Git push origin master. So let's wait. Yeah, so it is pushing and it is done. And if you go back to the remote repository, and if you refresh this remote repository, do you see the browser? So is it visible, the screen?
Yes, it is visible, sir.
Okay. Thank you. Yeah, so if you refresh here in the remote repository, yes, now the developer one change, we got it to the remote repository. So that means as we are talking that developer one he has done and he has pushed the changes to the remote repository. Okay, good. No issues. Now let's come back to the developer two activity. Developer two, he doesn't know about the developer one, the changes which has done, and he has pushed the changes. So he doesn't know that, developer two. So developer two is also at the same time, he is also trying to do this modification. Okay, I'll do that from the developer two side. Now, opening the Docker file. Now, what is the state? He's having the 4 lines, right? He's having the 4 lines. Now he has to add it his content as per the implementation of the Docker file. He's going to add that his content. That is in the line number 5. So updating, committing, and pushing. Let's try to do that from the developer 2 point of view. So let's go back to the developer 2. Developer 2 is nothing but EC2 instance we are talking that. Let me take it this EC2 instance. And what is having this now the Docker file? 4 lines of the change. Okay, good. So he's going to editing this file. And the same file, same line. Yeah, so this is 5th line from developer 2. So this is the content. His content he is adding. Developer 1 he has done his content and he has pushed it to the remote also. But developer 2 now he is doing on the same file and he's trying to edit his content in the file. So let's save this file. Now git status if you verify. Yeah, Docker file has been modified. And git diff if you run it, we can see the changes also. Yeah, so this is a new line which has been added in the workspace. So it is comparing the previous state and current state. Yes, this is the line which is modified in this Docker file. That is git diff command. Diff command is helping to know the difference of the previous committed to the current changes. Yes, in the workspace, this is the change which we have done now. Okay, I'm good with the change. Now I need to add it and commit it. But adding and committing, one more prerequisite as we are talking that, have we configured that user properties? Have configured the username and email ID of this user? We didn't configure it. So let me show the issue now. Okay, now what I need to do? First, I need to edit the file. Okay, I have added. Adding time, I don't have any issue. But whenever I'm committing that, So this is a Docker file change from developer 2. It is not accepting. You see that? So I'm trying to commit it. What it is saying, this is EC2 default user. Okay, fine. Your name and email address were configured automatically based on about your username and host name. Yes, by default, it is taking that from the host name. I mean, whatever the user we have this on this host, that username and host name, it is taken that, but that is not recommended. So what do we do? That is, we go for updating this one. That's why, as we are talking that first, whenever you are starting the configuration, yeah, so it is not yet configured that's list. Let's define that username and email ID. So how do we define that username and email ID? User
Name.
name. I'm going to define this one as a developer2. Next, another property, user dot email. I'm just defining some dummy email ID. Or if others like, you can give that about your email ID also, no issues. Okay, username and email ID has been configured. Now, if I try to commit it, then it will be good. But it is already taken that. So that's why, like, before going to do the configuration, make sure that username and email ID has been configured. Now, what was happened if you see this in the Git log? It was taken in this commit. We didn't configure it, right? First username and email ID. What is the username it is taken is the current system username and host name it has been taken. But this is not recommended actually. So that's why make sure it once the Git has been installed, first to configure about username and email ID. So are you clear about that importance of that username and email ID committed time? So it is going to track that these two properties. If it is not there, the system level properties, it is taking that the system username and host name. Are you clear this now?
Yes, sir. As of now.
Yeah, so the most similar command, sorry. Yeah, nothing to commit, working tree is clean. That is already committed to the local repository. Fine, local repository has been committed. But whether it has been updated to the remote, let's try to refresh in the remote. No, right? So this is a fifth line from the developer one we have, but developer two, we didn't receive it. Now what the developer two has to do? Has to push to the remote repository. And one more point here. So he's trying to pushing is nothing but yes, it is asking that username and password. So username, the same username which you are using to while log in the GitHub, you can use it. But what is the password? Where do you get the password? How to get the password of this? I need to go to the
settings.
settings. Yes. Developer settings. Personal
Download
access tokens. Token generate the new token. Let's confirm it. Yeah, I'm going to define this one is for that some identification developer 2. Yeah, let me give the permissions. So command line, yes, you are using the command line to connect to the GitHub, then you should not use a normal password. You should generate the token key. Copilot not required for us. Yeah, sh generate token key. Yes, this token key, copy it and paste somewhere. So that would be helpful. Control N and Control V. Okay, so now let's go back to the EC2 instance and enter that key. Yeah, so now it is trying to pushing to the remote repository, but whenever it is trying to push that, you see that it is rejected the changes. So failed to push some differences to the remote repository. So why it is failed is updates were rejected because the remote contains work. The remote contains the work that you don't have the locally. Yeah, remote is having some advanced changes than which you don't have in your local system. So if you have this kind of issue, what you need to do this is, first what you need to do, get the remote repository changes to the local one. Yeah, now this developer is trying to push to the remote repository, but it is not accepting by the remote repository because the remote repository is having in the same file, same line, some advanced commit than about your commit. So if it is accepted about the developer to commit, either it has to override it. If it is override, developer one changes, he is going to losing that. Or if it is going to appending that, no, it should not append it. Then the business logic is going to changing. So you should not do append, you should not override it. It should not take the decision by the Git itself. So that's why it is rejected, his changes. Now what this developer has to do is, he has to first get the remote repository changes to the local one. So what is the command to get the remote repository changes to the local one? Git pull. So whenever you have the conflicts, first to get the remote repository changes to the local one. Because you should not directly do that in the remote. So first take it to about your local system and do the update and then recommit it. Yeah, now what it is saying is git pull origin master, total 3 objects, it is got it, some changes. Yeah, you have divergent branches and need to specify how to reconcile them. You can do so by running one of the following commands sometime before your next pull. Yeah, so here what you like to do that is you need to merge the changes. So do this configuration. The pull rebase as a false, you need to set this property. And let's go ahead and once again try to pull it. Yeah, whenever we are trying to pull it, so auto merging of the Docker file. So it has been raised the conflict, merge conflict in the Docker file, and automatic merge failed, fix conflicts, and then commit the result. Yeah, now it is trying to get that remote repository changes to the local one. And it is trying to merging, we are defining the merge operation, but merging got failed. So fix the conflicts and then commit the result. Now what I need to do that? It is saying that's merge failed. What I need to do is, so we need to use this tool. So run the, whenever you have the merge conflicts, yes, first to pull the code, then run this command. What is the command? Git merge tool. So what this merge tool is going to do, that is it is going to scan that all the files wherever you have the conflicts, and it is going to identify that. Yes, it is identifying that merging in the Docker file, some conflict. So conflict for the Docker file, and it is going to ask us to open that in the diff tool. So now we need to identify that. So about your local file, what are the change you have done? Remote developer, I mean, that's yes, other developers, what are the change they have done? We should know it, right? So to know that, about remote file and about our local file, we need to open in the Vim div. That is a diff file. Just enter that. Yes, now it starts in the diff tool. Total 4 editors. You see that here. So now first editor is a local file. That means this developer file, developer2 file. This is, this file, third editor is developer, other developers file. So here we are talking the developer one. That's it. Normally we can say other developer file. So this is a developer one changes. You see that? So this is the fifth line from the developer one. And this is the fifth line from the developer two. This is the local file. And this is the other developer file. And this is the actual file. Before this developer committing the changes or pushing to the remote repository, what was the change actually? This is actual file. So on the actual file, this developer has done this modification and I have done this modification. That is the conclusion. Once you got this conclusion, then if you have the clarity about it, okay, this developer one has done his change and this is my change. So I need to replace this line at, my line at this location, or I need to change the developer one code. If you have the clarity, you can do that. But if you don't have the clarity, then you need to discuss with the developer one. Boss, we have the conflict. Please let me know this line. Is it required? This line position, is it the fifth line or sixth line? Because the business logic is important. If the line order is changed, the sequence is changed, functionality is going to change that. So simply moving that this line and after the next line, my line, no, not like that. You need to have the clarity. So this developer, whatever he has implemented, so this is required to have it in this position, or my code is required in the next line or before this line. So that's, you need to get the clarity communicating with the developer too, and the conclusion coming to that. And finally, in the fourth editor, you see that now this, now here you can edit it and you can do the changes as per the requirement. How do we edit that? We know that we editor. So let's go to that insert mode. Yes, whenever I type press that I, now it has been changed to the insert mode. Now you can do the conflict. Here it is raised. Yes, this line is required. Yeah, unnecessary content, remove that. Yeah, now we got it like this is fifth line from the developer 2 and developer 1, or if you need the sequence to change it. So take this one and go back and replace it. The DD and the paste. That is VA editor commands, which you can use it. You can change the order or whatever it is required. Now I'm good with this order. And if you are not having the clarity, then you need to discuss with the other developers. Are you clear at this point? Now save this file. That is a :wq. That is the fourth editor. But remaining 3 editors, we don't need to work at anything. Just to close these things. :q, :q. Yes, finally, we have resolved that issue. Now, if you verify the Docker file content, yes, developer 1, we got it, and developer 2 changes, we got it. So now this file, now one more file. If you verify the status command, you see this one new file has been created, temporary one file. So this file is no more required. So you can remove this file. Don't commit this file. This is temporary file. While merging it is created, you can remove that file. Now, the status wise, if you verify, yes, this is the file which are modified. And let's go ahead, commit first to stage it. Yeah, so while committing itself, we can stage it, right? -a, -m. And this is after matching, our conflicts have been resolved. So you can just write it some content over here, some message, and after matching, now you can push git push origin and master. So let me enter that key over here. Yes, now we are good. It is updated to the remote repository. And if you go back to the remote repository and if you refresh that, yes, you see the software merging. Yeah, so developer 1 changes we have and developer 2 changes also we have that. Are you clear about this? How do you resolve the conflicts?
So we can edit the files directly in GitHub here.
But you didn't get that developer 2 changes, right? Developer 2 changes that is in the EC2 instance.
Mhm.
It was not accepting, right, to push it. Whenever the developer 2 is trying to push it, he got the conflict. So without having in the remote repository, how do we do the changes here? So that is in the developer side itself, he has to complete it. So whenever we have the conflict, simple. First pull it, git pull, then run the git merge tool, and which opens that the merge conflicts in the V editor, Vim diff if you use it. Fourth editor, use the insert mode and identify about your local changes and the remote changes in the first editor and third editor. Then as per the changes, apply that in the fourth editor and save it, commit it and push back. So this is actual process. If you have the conflict, pull it, open in the merge tool and identify the changes and fix it and recommit back to the remote repository. So what is the additional command we got? It is git merge tool with Vim diff. Yes or no? Interesting, right?
Yes, sir. Yes, sir.
Real-time scenario. This is one of the important activity, but how do we overcome that? Suppose what is the developer has done the mistake here? Suppose here, if you just talk it, one
So
case.
developer 2 has to pull the data before he do any changes, commit.
Yes, exactly. Suppose let's think it I'm the developer 1 and you are the developer 2. So I went on leave for 2 days. 2 days I was in the leave and today I came to the office. Meanwhile, this developer he has done some modifications and he has pushed it to the remote repository. But what was my current state? 2 days back state, right? My local repository. So if I didn't do that any update, and if I started editing the files and if I modify the file and if I commit and push to the remote repository, then you will be having the more chance of conflicts. Because 2 days files, other developer they have updated here. And you didn't update about your repository, but you have edited and you are trying to modify it to the 2 days before the state you are using and you are trying to commit is nothing but whenever it is checking about that, about your local files to the remote repository, a lot of changes it has been applied already by the other developers. Then whenever you are pushing, you will be definitely having the conflicts. But resolving those conflicts, and again, that is a big headache, like communicating other developers, because their code should not get impacted because of whatever changes. So how do I overcome that problem is simple. So once I come back to that office, first what I need to do is I need to update the remote repository to my local repository as per the latest state. Then go for editing the files or updating the files or creating a file. Okay, anyway, there is no conflict about that is a new file you are creating. But especially common modules, common modules or the common files among the development team or as like infrastructure as a code which you are using that during that time. So we'll be having the challenges. Suppose let me close that scenario by replicating that. What I do is let me go to the developer one. Now the developer one, what is having the state? Now if you check it like a git status, everything is clean to him. Sorry. Nothing to commit it. But remote repositories are having latest change, right? If you verify that's in the local Docker file, he's having only developer one changes. Developer two changes he doesn't have. But I need to work it on this Docker file. So, but before going to edit the Docker file, if I edit it and if I do add the content in the next line, but next line is already updated in the remote repository, what I need to do first? Before going to edit it, I need to update my repository. Git pull origin from the branch, that is a master branch. If I do update it, then I will get that the remote repository changes to my local repository. Okay, now this developer one knows, okay, so he has done this change. So as per this change, maybe sometimes, actually I am also planning the same change, but the other developer has done. Now I don't need that. Now I can use it this file. Or if you'd like to add it about your content, yes, now you can add it. Then you don't see any conflicts whenever you are pushing to the remote repository. So how do you work on the conflicts is always keep on update about your local repository with remote. That is recommended. If you are going to edit the files before that, especially common modules, update it, then do the changes. Then you don't see the conflicts. Are you clear about this parallel development scenario?
Yes, sir, perfect.
Yes, sir.
Yeah, so developer one and developer two, and developer one has done the changes and he has pushed it. And yeah, developer two has done the changes and he has pushed it and leads to conflict. Whenever you have the conflict, simple command, git merge tool, and open this in the V editor, the merge window, select the respective changes, then save and quit it, and add it, commit it, and push it. Yeah, so that's about the one important real-time scenario or the daily activities point of view, which we should know that. And even in interviews also, they stress about that. So if you have the conflicts, what do you need to do that, or how to fix that? Yeah, good. So let's move into that. Next, the important concept. Now, so far we understand about the Git the commands from the developer side. But versioning systems, how do we manage that? So we are not going to use it application side only version, right? So as the sprints which are coming that every 2 weeks, that's the new sprints. They keep on getting the activities or the tasks. But the tasks wise, how do we manage the source codes? Sometimes you are working on the bug fixes or hot fixes. Sometimes you are working on the minor releases. Sometimes you are working on the major releases. Sometimes you are working on the patches. But how do we handle that? The different the versions point of your patches or whatever it is. So how do you handle about the source code? So that's which we should know that a directory structure. A directory structure, this is not only just for Git. So even you are working for the SVN or any version controlling tool. So this is a generic concept. Directory. Suppose in our the Windows also or Linux file system, if we take it like a directory structure, which we use it or not. Is why you are using the D drive, E drive, F drive, or C drive, just keep the C drive, right? Everything like a 500 GB hard disk, which you got it from about your hard disk, just keep it in the C drive. Why do you need the D drive, E drive, all these things? The maintenance activities. Yes, all my materials into one directory, all my entertainment related files into my photos, images into another directory. So I'm going to classify that, categorizing that, easy to manage it. That is the directory structure. The same way in the version controlling tool, if you are going to talk about the directory structure, is nothing but yes, you can create multiple directories. Now, master, whatever the branch we are talking, that is one of the directory. So what are the files you are pushing or committing, everything that is storing in that directory. But can I create a different directories for the different versions? Yes, that's we can create it. But what are the main directory structure? That's we follow that. In the version controlling is master or main. GitLab, if you are working, you will get it. Main is the default branch. And if you are working with the GitHub, we got it some default branch, master branch. That is on the base of remote repository. Maybe branch names are the different, but master or main branch is the root directory. And this is a root directory and a default one. Git init, that is a local repository you have created. Yes, that is going to create one repository, one branch. What is the default branch? Master branch. Or yesterday we have created the repository in the GitHub. That is created one branch. What is the default branch? Master. Yes, master main is the default branch, and we can say this is the root directory. Like how we have the C drive or root folder in the Linux operating system. So the same way, master or main is a root directory. But as per the releases point of view, that is versions point of view, we create multiple branches. Branches we have like, I'll conclude that the branches, how do we manage it in the real world? Next, we'll come back. So developers are, as a DevOps engineer, whenever we are committing the files or pushing the files is nothing but mostly we use the branches. We don't directly commit to the master or main branches. So we create we can create a number of temporary branches. And whenever you are working, suppose I am working on the Ansible and you are working on the Dockers. Yeah, I can create separate branch for my Ansible and Ansible module implementation point of view. I can keep on the separate branch where I don't have any conflicts with other team members. Or whenever you are working on the Docker as a specific module, then you can create about your own branch. Yes, on the basis of the modules or on the basis of the versions. We can create a branches and we do the committing the files to the branches. Yeah, branches. So where the developers or the DevOps teams, we use it to commit the files. But what about the tags? What about the master branch or the main branch? Master branch or the main branch is current production copy code. We will keep it in the master branch. Suppose in the current production application version is, suppose 6.0 is a version. That 6.0 application version related source code of the production, where do we manage it is, that is in the master branch or the main branch. But next to 6.1 they are working is nothing but that is separate branch. Current production is, that is a master or main branch which we use it. Directly we don't commit to this. But committing by the development team or DevOps teams, we use it, some temporary branches. So once this branch is ready, everything is okay, then we will take it, this branch code, and we will merge it to the master branch. Suppose 6.1 is released, that is a production. Then that 6.0 release copy will take it and we'll merge it to the master branch. Production is equal to master branch or the main branch. Current development is nothing but Our release is nothing but that's we'll manage it in the branches. Then what about the tags? Tags are, suppose 6.0 version, you have this about your application currently is nothing but previous 5.x versions, 4.x versions, 3.x versions, all the versions you need to manage it or not. As a backup reference. And these are all the read-only copies. Suppose 6.0 is released and it is finalized is nothing but that should be read-only. That is a finalized release copy. Release copy we should not update it. But if you need to update any bug fixes on it, then you need to add it some patch number and release that. That is 6.0.1. That is the next patch. The issue of the 6.00. But 6.0.1, where do we manage it? Or how do we handle that is, that's we created tag. It is a reference of a bug fix. And it is always read only. Yeah, there are the three main directory structures which we use it. Branches, current implementation or current release copies. And the master or main branch, that is a current production copy, master copy. And the tags, these are all the, once release is done, that's we tag it. That means read only copy. Nobody should not change it, that as a feature reference. Yeah, we create a branch whenever we want to develop a new feature or to do a bug fix of it. So unstable code is never committed to the main or master branch. Yes, as we are talking that it is a production copy. Unstable code we never commit or we never update it to the master branch. Yeah, real world branching scenario, if we just try to understand that, master branch is a production ready copy. So we can create, as we are talking that we can create multiple branches, right? Here's one development branch. It is a developers branch where continuous work which will be done by the development team. But within the development itself, they will be having that, I mean, as a sprints point of view, different teams, different features, they are going to work with that. So as we are talking that, so we are all working as a DevOps engineer, but I'm working on the Ansible and you are working on the some Jenkins file implementation. Then you can create about your the feature related branch, and I can create it my functionality related branch. So we can say the feature branches. Yeah, whenever the developers working on the new features, they use the feature branches and commit the code to that branch. Yeah, development branch can be split into different feature branches on the basis of developers, which they are working on the basis of their functionality. It can be split. But finally, development side, development is a main branch. But within the development, yes, different developers and different functionalities, they're going to work it, and they manage the different temporary branches. That's we say that feature branch. But finally, feature branch, which will be merged to the development branch. But once development is done, that is integration is done by the development team, but we need to use it, that code in the staging environment, UAT environment, production environment until the production getting ready. So you need to keep on testing all the scenarios or not. But you have released it to the UAT environment, and in UAT you found it some bugs, but the development team or that team, they need to fix it immediately. Then what is the branch that's we manage it during the release process? Once the developers commits, my code is ready. Okay, developers branch is ready. So we take it and we create it using the release branches. Yeah, this branch is created from the development branch to make it ready for the release, and it is used for the bug tracking and documentation purpose. Yes, whenever the code is in that like testing environments and testing related any issues immediately required to fix it and released by the development team, they work it on the release branches. So parallelly, they are working on the feature implementation. And during the release time, if they have any issues and if immediately required to fix it, yes, they work it on the release branches. But finally, release, once it is completed and approved, it will be merged to the master branch. And once release is approved and master branch is ready, is nothing but that's we take it one copy, that is backup copy, that is a tagging. Are you clear these points? Are you following the points?
Yes, sir.
I've got that like difference between the master main branches and the tags. Branches is you have the development branches, release branches, future branches, that is or hot fixes branches. That is on the basis of the requirement we can create temporary branches. But a branch concept is where we do the commit operation. Check-in, checkouts are like, commit operations will be done on the branches level. But a main master branch, that is like as a production copy, we will use it. And during the release time to track it, all the release related bugs and fixes, yes, we use a separate branch. And finally, once the release is done, and that release, if you need the backup copy is how to manage these tags. Tag, if you create it, that is a read-only copy. You cannot update it. Yeah, working with the commands like git, whatever the commands like add, commit, push, or blame commands or the logs commands, whatever we discussed so far, those commands are the universal, but we work those commands on the basis of either master branch or development branches or the release branches or the feature branches or the hotfix branches. That branches wise we'll work with that. Yeah, let me explain one real-time scenario over here. So how the branching model will be having. Suppose initially whenever we create a branch, what is the default branch we are going to have it? Master branch, right? The initially. So if you see this round circle, that is just assume that. So you have done some commits, updates to the branch. Okay, initially whenever we create a branch, the default branch is master branch. You need to create at least readme.md file, some basic file system of the project. That is source directories, web content directories, that is developers will take care of it. Yes, initial the repository, that is a master branch. But directly, are you going to work it on the master branch? No, we don't work it. What do we do? That is, we take the master branch, we go for creating a development branch. Understand the actions or activities, what we are going to have it in the branching model. So taking the master branch and create a new branch, that is development branch. Yeah, master branch, what are the files we have, the basic structure of the project, everything that will be taken, and it is going to create a new branch. That is, it is like as a copy directory. But which directory you are taking? Master directory you are taking, and you are going to create a new directory, that is development. Okay, whenever we are planning to start the development, yes, we take it from the master branch and we start the development. But as we are talking that the development, again, it can be split it into features wise, right?
Yes, correct.
Yeah, all the developers, they don't work it on the main branch, that is development branch. So on the basis of the features, which are starting as per the sprints, yes, we can create separate branches. Let's assume that from the development, feature 2 is starting. Feature 2 is starting. That means here, what is the activity? Take the development branch and create a new branch, that is feature 2 branch. So first activity, creating a branches. How do you create a branches? We will come back. But one of the activity in the directory structure, in the version controlling tool, creating a branches. But you are creating a branch is nothing but source branch, destination branch. Yes, here master is a source branch. Take the master branch and create a development branch. And here take the development branch and create a feature 2 branch. Okay, so feature 2 has been started. and some developers, they are working and they are committing to this feature to branch commit. They are updating some files. Parallelly development, yes, some other developers who are working on the common modules, common implementation, yes, they are committing to this branch as well as. So development is going on and the feature 2 enhancements also going on. Fine, good. But after this state, so what do we have this now is feature 1 has to be started. Okay, client is saying that feature 1 also started. Okay, some development, some common modules have been implemented. Take this current state and start the feature 1 branch. Start the feature 1 branch is nothing but take the current state of the development and create a new branch. That is new directory. That is feature 2. Sorry, feature 1. So all these activities, if we just observe that 2 activities we are understanding. Creating a branch, master to the development, or a development to the feature 2, or development to the feature 1. They're all like creating a branches. That is one activity, how to create a branch. Second activity is here the developers who are working on this branch, they need to commit the files to the development branch. The developers who are working on the feature 2, they need to commit to the feature 2 branch. So that is committing the branch. So how do I commit the files to the particular branch? This is one more activity which we should know. Yes, how do we create a branch, or how do I commit the files to the particular branch? If I'm working on the development, I need to commit to the development branch. If I'm working on the feature 2, I need to commit to the feature 2 branch. How do I commit my files to the particular branch? This is another kind of activity which we should know in the process. Sorry, something. Okay. Okay, now who is working on that on the feature 1? They need to commit the changes to the feature 1 branch, some implementation, some files. Okay, now the client, what it is saying is, okay, feature 1 parallelly continue and do some commits to the development also. Who are working on the main development module, they are committing the development changes. They are implementing and they are committing to the development branch. And who are working on the feature 1? So we don't see that one, I mean, we don't have only one developer, right? Multiple developers, parallel development is going on.
Yeah, of course.
Yes. So the feature 1, yes, who are working on that, they need to commit to the feature 1 branch. And who are working on the main development, yes, they need to commit the files to the development branch. Okay, now the current state, what do we have? That is, okay. I mean, finally 2 activities, either creating a branch, not either. Yes, one activity is creating a branch. Second activity is committed to the particular branch. Creating a branch. So here, and here committing to the development branch, here committing to the feature 2 branch, and here committing to the development branch, and here committing to the feature 1 branch. Okay, good. Now it's going on. Now feature 1 is ready. So client, the feature 1, okay, boss, that is ready. So let's move to this release. And some development changes also. Okay, feature 1 has been started here. That means current state of this development has been started and it is done some changes on the feature 1, and parallelly some development changes also done. Now this development and feature 1 is ready for release. Ready for release is nothing but what we need to do. This feature 1 branch, once it is complete, so take it this branch and merge it to the development branch. Directly we don't release this one, right?
Correct.
Yes, feature 1 has to be merge activity. Here, the new activity we are talking, that third activity, merging activity. So merge one branch with another branch. But which branch here? Feature 1 has to be merged to the development branch. This is the before release. If any features are ready, feature branches identified and merge to the main development branch. So development is going to have its commits. Feature is having its commits. Finally, it has to be merged these two. That is a merging activity. So third activity, what we are understanding in the process model? One is creating a branch. Second one is commit to the particular branch. Third is take this one branch and merge it to another branch. But here, feature one branch, merge it to the development branch. That is a before release. Okay, now the development is ready. So take this development and the developers confirmed and get ready for the release. That means take this release branch. So here, development branch, take it and create a release branch. Because developers, they need to start at the next feature. They don't wait until that this is getting ready, right? So parallelly, this release, okay, testing is going on. And they need to start, okay, after releasing it, they need to continue their next work. Development team. So, but in the SIT or UAT environments or load testing environments, if you have some errors, you need to track it or not. That is the release branch. Yeah, create a development to the release branch and use the release branch during the process, that is deployment and the testing process. And if you have any issues, fix the issues in the release branch itself. That is commits. Some commits we are expecting on the release branch. Okay, development branch has been taken and it is released. And during the release, if you have any issues, as it has been fixed here itself, now it is good. The release is done. That means conformed to the in the production environment. But in the production environment, it is conformed to this release is nothing but, let's assume this is a 1.0.0 version. But after releasing to the production, this release branch has to take it and it has to be merged to the master branch. Now the production, whatever that it has been released, that's we will manage it in the master branch. So far, what it has been released, master to the production of 1.0. 1.0 is released the feature branch changes and as well as some development changes. But feature 2 is not released. Feature 2 is still continuing that. That is in the next sprint. Are you clear about this process?
Yeah, sir.
Yeah, but here what are the activities we're expecting is development to the release branch creation. And during that, the process, release processes, if you have any issues, bug fixes which are required from the development team, they use the release branch and they fix it and they use that release branch. And once it is done, next, merge that release branch to the master branch. This is merging. But suppose here during the release, it is committed to some files here. But what's going to happen that to the development? Suppose in the next release, if they take it this development and if they continue for the release, whatever the issue which has been fixed here, that's we will be losing in the development, right? That means same issue which was faced in the previous iteration, in the next iteration also you'll be facing that. So what you need to do this is, this release branch needs to be measured back to the development also. So in the post-release, you have the two activities. Post-release, two activities. Once this release branch is ready, that means the release is ready is nothing but release branch merge to the master and as well as merge it back to the development also. Because if any issues which have been fixed in this release branch, bring it back to the development. Now the production, whatever you have released, same thing now you have in the development also. And developer says they are continuing that with the next release related features. Yes, feature 2 implementation and next, okay, that is merging to the development, then development to the release, release to that, yes, master and getting back to the development. This is a continuous iteration, right?
Yes, of course.
Are you clear about these points?
Clear, sir.
Yeah, the main activities, if you just try to understand it, total 4 activities. So if you are working with the branching activities, The 4 activities, remember that. But what are those 4 activities? Let me show that. If you go to the lab guides, have you started working on the, what's happened? Yeah, site is down. We need to check it. Okay, I'll check it once this task is over. Okay, fine, good. There's some bad gateways coming that. Backend services. Okay, I need to check it. I'll come back to that. But anyway, so let's continue that. So what are the main activities we are understanding here? Refer the lab guide, then you will get it idea. So what are the main activities we are expecting is, one is creating a branch. But whenever you're creating a branch, keep this in the mind, that is, which branch I need to take it and which branch I need to create it. Creating branch command is the same, but process-wise, which branch is the input and which branch is the destination output. Yeah, here the master to development, and here development to feature 2, here the development to feature 1, here the development to the release branch. Yes, they're all like a branch creations. Next, committing to the particular branch. Yes, here the development related activities committing to the development branch. Here feature 2, who is working on that, they need to commit to the feature 2 branch. Who is working on the feature 1, they need to commit to the feature 1 branch. Who is working on this release process to bug fixes? Yes, they need to fix that, or they need to commit that all those issues related fixes in this release branch. Yeah, committing to the particular branch. That is the second activity. Third activity is merging. Merging 2 scenarios will be having that. One is feature branch. Once it is ready, feature branch, we don't use it as a direct release. Feature branch is required to merge to the development branches. This is the before release. But after release merging activities, yes, release branch take it and merge it to the master branch and as well as development branch. This is post-release. Pre-release is feature branch merge to the development, and post-release is release branch merge to the master branches and as well as development branches. So how do we merge a branch? So here identify the source branch, release branch merge to the master, release branch merge to the development. Here the feature 1 branch merge to the development branch. Merge command is the same. So this is the third activity. So first creating a branch, second one is committing to the particular branch, third one is merging a branches. Fourth activity is tagging. Yeah, once release is once release is done, so what are the production copy which we have? This is we need to have the backup of it. Or at any time, if you would like to take that any branch as a backup, how do I take the backup? That is a tagging. How do I create a tags? How do I create a branches, or how do I create a tags? But branches wise, how do I merge a branch? Or commits also you'll be having on the branches, but the tags we don't have the commits, and we don't have the merges of the tags. Tags main activity creating a tag. So are we in the tags? Are you clear about the activities on the branching strategy? Total 4 activities we are getting. Creating a branches, creating a tags, committing to the particular branch, or merging a branches. Yes, there are the 4 activities. But what are those 4 activities and how do you work with that? We look into that from the tomorrow class. That is about Git commands. Simple, for 5 or 6 commands are available. If you know that, but process is important. We'll see this practically. How do we work with this entire process? With a branching strategy, we'll create branches and we'll commit the files, we'll measure branches, we'll tag it. We'll try to replicate it in this demo. But before replicating this, we should know commands about creating a branches or deleting a branches. Suppose future branches, they're all temporary branches. Once it has been used, we don't use it. So once feature branch is matched to the development, really remove this feature branch. Why do you need it? Already you got the same code in the development, right? Yeah, the feature branches are the temporary, but once the temporary is over, then we need to delete those branches. How do I delete a branch? Locally and remotely. Yeah, so these things tomorrow will come back to that. That is the main activity. Yeah, once if you've done this activity, that's almost Git related activities have been completed. Some other commands we have. Stashing is one concept. So then there's nothing. Yeah, good. So that's all from my side. So any queries, questions, please? Today, what we got it? Or do you understand the concepts?
So how to release management, directory structure,
Yeah.
and how to compare then Git before committing.
Yes. Comparisons, and as well as one more important point, conflicts, how do we resolve it?
Yes.
Yeah.
That is a interview question, sir. The last time I was faced.
Each point is important, and so we should not say this is only important. I mean, interview or that's one only. So, like, if you are suppose today itself, if you just talk it, how do we create a branches? How do we switch that branches? How do we measure branches? How do we resolve the conflicts? How do we view that the content wise the difference, that is git diff command? So today itself, if we just talk it, 4 or 5 interview questions which we discussed, but concept wise also, yes, real time, that parallel development, a real time use case. Every day you are working the season first to make sure about your updating your local repository with remote one, then start working on it. So that is a basic funda. There are all the basic fundas which are required for the DevOps engineer. And even sometimes the developer, they come up with that, keep on, suppose new developer has joined and he is a fresher and he's keep on facing the problems. Then you need to take the training for them. First, don't do this like this. And if you're going to do any changes, first update it. And then only you start working on it. Yeah, sometimes, yes, on these branches wise or these activities wise, we need to help to the development team as well as. So those context, I mean, in that context also, we should know the Git. Yeah, so is it clear? Any queries, questions, please?
That's all good.
Yeah, thank you. Thank you all. So that's all from my side for today. So we'll meet tomorrow and we'll continue the Git commands. And if the time permits, we'll start about today, whatever we are understanding about. Yeah, this scenario, we'll try to replicate it with the Git commands. Yeah, thank you. Thank you all.